Hi and welcome to this iOS 6 video presentation on object-oriented programming. We're going to begin our discussion with object-oriented programming with the concept of what is a class. Well, a class is, I have a definition here, but we'll talk about that. A class is an object-oriented abstraction of a real-world type or idea. A type can be a thing, like a car, or it can be an idea, like an account. Classes really function as templates or blueprints for producing instances of themselves. So we set up a class describing some classification of real-world objects or real-world things or ideas, and then we make instances of these classes and work with those. And we call the instances objects. So classes, for their objects, will declare two broad categories of things. They will declare properties, which are attributes of the system that we're modeling, and they will declare methods. Methods are like C functions, except they belong to the class itself, and methods describe what the class can do. So in object-oriented programming, OOP, the terms instance of a class and object are interchangeable. We say that, we'll talk about this a little bit later, but we say that we instantiate a class, we make an instance of a class, and that is the object of that class's type. Now, in Objective-C, classes are types, just like ints and floats and stuff. Classes are pointer types, though, and objects are all pointers. They are allocated on the heap. So here's an example of a class. We can say that a class named car, and oh, by the way, by convention, our class names all begin with an uppercase letter, and property and method names begin with a lowercase letter, and they're in camel case. In other words, they begin with a lowercase letter, and then all the words are run together with each word after the first being capitalized. So we can say that a class named car would have properties. It has color, number of seats, maximum speed, and so forth. Now, these properties aren't defined in the class, but they are declared in the class. A car would also have methods: accelerate, brake, and turn, and so forth. Now, the methods are defined in the class because they function in the same way for each instance of the class. So, a car is just an idea. It's just a blueprint. It's not really a specific car. It's the idea for a car. If we want to make a real car, then we have to instantiate a car from the car class. So one specific instance might be called my car. We can talk about my car because we can talk about my car in terms of it being blue, it having 4 seats, it having a top speed of 120 miles an hour, and so forth. My car is also capable of performing all of car's methods. So we define the properties that are declared in car. In other words, car just had maybe an int variable, an int property called seats. But in my car, we assign the value 4 to seats, and that way we know that my car has 4 seats. Somebody else's car might only have 2. So some terminology about all of this, or wrapped around all of this. We say that my car is an instance of car, and we kind of talked about that before. My car is also an object of type car, and we've already said that this instance of and object of type is interchangeable terminology. We can make as many cars as we want. There can exist infinite objects of type car, but there can only exist one my car object at any given time. Now, of course, in object-oriented programming, just as in real life, we can change some of the properties of my car over time, but as an entity, as an object, my car can only exist It is unique. So again, in object-oriented programming, when we take a class and we create an instance of it, or make an object of its type, remember, interchangeable language, this is called instantiation. We instantiate a class to create an object of the class's type. So this is important language, because throughout the course you'll hear me say, oh, we're working with an instance, or we're working with an object, or we perform this instantiation technique, or so on and so forth. So that's a very important word to know. Classes can also inherit from one another. So the way this works is that any class can have one or more children, or one or more subclasses. So these are classes, but they're subclasses of the primary class. So for example, car might have two subclasses, a sedan and a coupe. It could have more. It could have a sports car. It could have several different kinds of car, but they're all subclasses of car. The cool thing about this is that sedan and coupe, for example, will inherit the properties and the methods from car. So subclasses inherit properties and methods from their superclass. We don't have to redeclare the fact that a sedan can accelerate. We know it can accelerate because it is a car. In some languages, classes can inherit, they can get these properties and methods from more than one class, and this is called multiple inheritance. In Objective-C, there is no multiple inheritance. And multiple inheritance is allowed in languages like C++ and Eiffel, for example, but in Objective-C there is no direct multiple inheritance. But if you're familiar with Java programming, you know that there's a concept called interfaces, where we can declare properties and method headers. We have that in Objective-C. They're called protocols, and we'll talk about those in detail in Unit 3. But these protocols can be used to mimic a kind of multiple inheritance behavior, but it's not full multiple inheritance. There's also a concept that's talked about a great deal in many different ways. But basically, encapsulation refers to the fact that classes will hide the details of their implementation. Well, why? Well, let's say you're working in a team of programmers, and you assign a specific class or graph of classes to someone to produce for you. You don't care how they implement it as long as it works. So that class hides the details of their implementation. One way that they do this, the primary way they do this, is that they will declare methods to access and change the values of their properties rather than allowing people to directly access those properties. And this is good. The methods that we're talking about here are called getters and setters. We use getters to access the value of a property, to get it, and we use setters to set a value of a property. So this idea that a class hides the details of its implementation and it controls access to its properties, this whole idea is called encapsulation. Now, in this discussion, I've given you kind of a high-level overview of some object-oriented terminology that we'll use throughout the course. And there is more, and we'll be talking about object-oriented programming and concepts throughout the course as we go along. But the reason that I've done this this presentation for you is to present some of these terms so that they're not foreign terms when we get to them later. Thank you very much.